Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to Complexity Made Simple. My name is Paul Allen and the topic of today's newsletter is the signal versus the noise. The key to continuous improvement. The key to problem solving. We are looking at signal versus noise. If you don't understand this, you won't get your continuous improvement right. You won't get your problem solving right. So let's get into this subject. Okay, look, I've said this before. Your processes are all big random number generators. I'm a manufacturing guy. This applies to manufacturing systems, but it also applies to systems that are delivering services. Whether it's your website, whether it's an insurance quote, whatever it happens to be, your processes are big random number generators when it comes to your key performance indicators. Now I'm going to look at this from a manufacturing point of view, but this would apply to the service sector just as well. So let's have a look. What does a big random number generator look like? Well, if we put it on a graph, it's going to look like this. Yeah, process is just randomly bouncing across the graph there. Sometimes a little better, sometimes a little worse. Of course, in a manufacturing situation, what are we typically trying to do? We're trying to hit a nominal. We're trying to get this process between tolerances. So let's just drop those numbers on the graph a second. Okay. There's the nominal, there's the target that we're after. There's the upper tolerance. There's the lower tolerance. Okay, now then, let's look at this thing. Is my problem the ability to hit the center? To hit the target? Actually, no. The center of my results is sitting right where I need it to be. Slap on the nominal. My problem is that I have too much spread around that setting. In other words, I have problem with noise. I don't have problem with the signal. The signal is the middle. I've got the middle sitting smack on target. So my problem here is with noise. Now if I draw that in a slightly different way, it's going to look like this. Let's draw that as a distribution. Let's put the tolerances on this thing. What's it going to look like? Well, it's going to look like sitting in the right place, but I've got defects to the bottom, defects to the top, and to be honest, there is nothing the operator can do about this. In fact, if you encourage the operator to try and deal with this problem, what will they do? Well, they'll wind this distribution backwards and forwards, and typically they will make it worse. That is a problem with noise. Okay, now let's have a look at a problem where the problem is the signal. Got the same process in a sense. We've got the random number generator bouncing around. Okay, we'll put an upper tolerance on this thing. There it is. We'll put a lower tolerance on there, and we'll put the middle. There's the nominal that we're aiming for. Now what's my problem? Well, my problem is the whole thing's sitting too low. This is a problem with signal. The signal is the mean, the average of your process. Now this is a problem that I haven't got the signal sitting on target. Here's the target here, T, the middle of the tolerance. This is a problem with signal. Now let's draw that distribution. Let's see what I get. typically have is something that's looking like this. Lots of defects out here. The other tolerance is sitting right over there. This is a problem with signal. This is a problem with noise. Now, why are these things important to you? Here's the deal, folks. This drives your problem solving approach. This drives your problem solving activity and how you need to look at these two issues. Because typically, this one here, getting rid of the noise will take 3 months to do. Yes, it will. It's going to take 3 months. You can't fix this in 3 days. It's going to take you 3 months. You are going to need a team. And you are going to need management sponsorship. In other words, the management is responsible for this problem. Lots of the reasons why this problem exists are deep inside your company. They are policies and procedures often, your purchasing routines, your maintenance routines, your training routines. These can't be fixed in 3 days, okay? How about this thing down here? Well, down here, typically, this can often be fixed by one person. They can often fix it in 3 minutes, 3 hours, 3 days. In other words, it's a very quick fix. Okay, so often 3 minutes. This is often some simple dial, so it's a dial on a machine. It could be that the reason why you have this problem, maybe the wrong piece of paperwork is being used in a service process, and you just have to use the right piece of paperwork, and the whole process moves in terms of time. This could be how fast you're providing the service, for example. A little bit too slow, and it's because you're using an overcomplicated process. Maybe you switch the process. Very simple to do. One person. It's a decision that maybe one person can take in 3 minutes. Typically, what's going on, folks? You've got your money-making process. You have a process that you want to use to make money. That's what all your processes are supposed to be doing. You're supposed to be making money. What you've got is a series of inputs. And of course some measurable outputs, some service that you're providing to the customer, a dimension, a tolerance that you're trying to hit maybe. This problem up here, what's typically happening is you have too much variability coming into each one of these. And when you have too much variability coming in, you are going to get too much variability coming out, and you are going to get a problem with noise. Now, as I say, these are often deep-seated. They may be that you haven't provided the maintenance on your equipment, so the machine is behaving badly, and then the operator is trying to buy that bad behavior off by adjusting settings. So you have settings that are being moved. You have the condition of the equipment which is moving around. That's too much variability. You might also have poor quality material coming in here. Yeah, so you might be buying cheap material. These things cannot be fixed overnight. You cannot just put all the maintenance issues right overnight. That's why if you say I'm going to do better maintenance, okay, great. That won't play through till a couple of months. You're going to buy better material maybe, or you're going to put a tighter tolerance on a previous machine. Again, that won't play through instantaneously. Don't forget, all of these things have got to be changed to bring this in. Here what's happening is maybe you had some standard settings and an untrained operator has inadvertently taken one of the values somewhere new. And all you've basically got to do is go up to the machine, audit the settings, and put the dial back to where it should be. That's going to take you 3 minutes to do that. It's going to center the process. So this takes 3 minutes, this takes 3 months. You've got to know whether you're dealing with signal or noise. And of course, it's very easy. Plot a graph. plot a graph, you'll see whether it's signal or noise. Now then, what they typically say is 90% of your problems are noise related. In other words, 90% need 3 months to fix the problem. What are you doing 90% of the time? Well, they say 90% of the time, the action that you're taking is to spend 3 minutes trying to fix it. In other words, you let an operator play with the dials up here. What will the operator do if he plays with the dials up here? Typically, he makes it worse. They say 90% of the time when an operator adjusts a machine, 90% of the time, he makes it worse. Think about that for a second. You need to know the difference between signal and noise. The operator is in charge of the signal. The management is in charge of the noise. And if you don't know the difference, what you end up doing is lots of this. Your problem disappears maybe for a day or two, but then it keeps coming back. Yeah, and you put lots of effort in and the problem comes back. You put lots of effort in and the problem comes back. Why is that? You don't know the difference between signal and noise. Signal and noise. It's the key to true problem solving. Signal versus noise. It's the key to true continuous.